Okay, let me know if you're not able to see my PowerPoint slides. Yeah, I'm sharing my screen now. Okay, let's look at the application of equation. All right, so if you can see on the screen here, we have a triangular object and it's given all the coordinates you have. So in this case, we have I, J, and M. So take note on the direction of the labeling. I, J, and M anticlockwise. I is at 0, -1. J point is 2, 0. Point M is 0, 1. Yeah. So don't confuse with the other numbering. For example, I equal 1 means point number 1. J equal 2, point number 2. M equal 3 means point number 3. So in this chapter 6, yeah, this is the error that student will make mistakes, where every time they confuse with the point 1, they will put 1 there. In this chapter, you need to look at the coordinate on the plane itself. Yeah, so don't confuse with the chapter 3, chapter 4. In this chapter, you need to look at the coordinate on the plane, because just now the 9 equation just now, we will use coordinate to calculate. Okay, so what we have here, it asks us to calculate the stiffness matrix for the elements shown here. The coordinate should be in, not inches, should be in meter. Okay, correction. All right. So assume that a plane stress condition, we have a plane stress condition, a modulus Young or elasticity constant value is given, Poisson ratio is given, Poisson ratio is 0.25, thickness is given, and the displacement in this case is given to you. The displacement in point 1, u and v is given, u in x direction, v is y direction. So displacement in all the point is given. So u, v is given. So 1, 2, 3.7. So 6 value is given. So it's speed up your calculation already. Determine the stress for this element. So how do we start? First, you use this equation. So this equation is specialized design for chapter 6. So if you look at chapter 6 or plane stress question, how you identify is a plane stress question in exam, you will see assume plane stress condition. When you see this line, it means it refers to chapter 6. All right, so when you see this word, assume plane stress condition, first equation you write on the answer sheet is this one. K matrix equal to TAB transpose DB, this matrix. You write this one, you get 1 mark for the equation. Okay. Yeah, so for chapter 6 question, you look for the keyword in the answer, in the question. Assume plane stress condition. First steps, write this equation, you get 1 mark. Then you will evaluate this one based on the value that we have in the previous slides. You refer to the previous slides. So what is A, what is B, what is D? You substitute inside there. So recall, so how you get all the A or the B value from these slides around. So you can refer back. So what is A? A, B, C, D, A, alpha, beta, and gamma. So this 9 equation will give you the value inside this matrix. Yeah. So for example, alpha I equal to xjym minus yjxn. So this one I copy from these slides. I copy this one. So there are 9 equations you need to solve. I show you the first one. So this one, I copy this one to the answer sheet. This one. So how do you, there are 9 so I show you 9 on my slides. So for 2D problems, we don't need the alpha parameter at this moment, right? Because if you look at the equation that we start off, K equal to TAB transpose DB. Here, we don't have alpha entity here. So we at this moment, we don't need the alpha. We only look at the 6 equation. 9, we choose 6, right? Then we calculate the BI, BJ, BM, gamma 1, gamma J, gamma M with all the coordinates here. Okay, for example, I do it for the first one for you. Beta I equal to J, Yj minus Ym. So what does this mean? It means you look at the diagram. Yj means coordinate of your J point. So if a J point, you have X and Y coordinate. Yj means you refer to the 0 here. So 0. Ym, it means you refer to the M point, Y coordinate. M point, Y coordinate is 1. M point, Y coordinate is 1. So the equation is 0 minus 1, you get minus 1. So you get the first one. Okay. Clear, Singi? Do you understand how to get minus 1?
Yes, understand.
Okay, good. Let me check Katana back already. Right, Katana, you're back, right? So do you understand, Katana? Do you understand beta I, why suddenly become negative 1? You understand?
No.
Okay, when you log in, where are we?
You are looking at the 9 equations.
Okay, then good. So when I mention 9 equation, right? Okay, this one, the 9 equation here. So I explain again. So alpha I, alpha J, alpha M, you have all these equations. So what is X, J, Y, M mean? Refer to this diagram. So you have 3 points there. Point I, point J, point M. Each point you have coordinate. So you have X and Y coordinate. If you are referring to the first point I, you have your XI, YI, correct, Katana?
Yes.
Then you refer to J, you have your XJ, YJ. If you refer to M, you have your XM, YM. So what you do, if you want to calculate the alpha I, you just use this equation. XJ, it means refer to J coordinate, J point, X direct, X coordinate, XJ here. YM, it means to point M, Y coordinate, and so on. You clear about this one? All this notation, Katana?
Yes.
Okay. Now back to these slides. So now do you understand why you get 0 minus 1 based on the question itself?
Oh, yes. Use the coordinates. Okay.
Yeah. You understand why you get 0, right? Yj minus ym. You understand, huh?
Yes.
Okay. Now it's just a small question for you, Katana. Try to answer B beta J. What is the answer for beta J? Singi, you answer for beta M. Lai, you answer for gamma I. So Katana, you calculate this one. Beta J equal to what? Based on the diagram that you see on the screen here. So Katana, what is Ym according to this diagram?
Is it 1?
I asked you to calculate beta J. What is the answer for beta J? Just now I explained about beta I, right? You understand why we suddenly get minus 1. I want you to solve this one. Beta J. Beta J equal to Ym minus Yi. So what is Ym according to this diagram?
Is it
What is Ym value?
wait, so for this let's say 1 point where I is equals to 1. 0 minus 1. This is x and y coordinate, is it?
You understand what is yj or not? You understand what is yj? What is the notation of y sub j? You understand what is this? You understand what is this?
The j in y direction, right? It's,
Is a coordinate of j in
yes.
y coordinate. In y, yeah. So what is the ym? What is this value? If you look at this
Okay,
diagram.
could you go back to the previous slide?
No, you look at this diagram. You already understand what is, yj, right?
Yes.
So if you look at this diagram, what is the point of j here? The j here, you have the coordinate 2, 0, right?
Yes.
So what is 2? 2 refer to x direction or y direction?
Is x.
Then y value is what?
Is it y?
No, I'm asking you, you have the j coordinate of 2, 0. So the first digit 2, right? 2 refer to x coordinate, correct?
Yes.
Then the y coordinate you see on the screen here is what?
Is 0, right?
So what is the y coordinate for j?
0.
0. So that's why y sub j you get 0.
Okay.
So y sub m, it refer to which point?
Here, m is equals to, where m is equals to 3.
No, again, don't confuse between the coordinate and the node number. Don't confuse between these two. M equal 3 means node number 3.
Okay.
This comma 0, 1 is the coordinate, the location of number point M. Don't confuse with 3 and the comma number.
Great.
Yeah.
So ym will be,
It will be what?
right. Okay, so the thing is, what is confusing me is if you remember the first diagram, it had like 3 axes, is it?
No, you refer to this. You refer to this diagram. So you understand what is yj minus y. What is yj, y sub j, y sub m or not? You understand this one or not? You understand what is the meaning of this one? I have to clear
No.
your, okay. You don't understand. I expand this diagram. Do you see this diagram? Can you
Yes.
see this? Okay, I break this diagram into 2 diagrams. I have 3 points here. I have not 1. I equal 1. I have not 1. J equal 2. I have not 2. I have M equal 3. I have not 3. I combine these 3, I get a triangular. Second diagram, I only have coordinate. So I have 1 coordinate, 0 minus 1. I get this coordinate on Cartesian plane. J, I have 1 coordinate, 2, 0. I plot on the graph. Then I have my M point with a coordinate 0, 1. Then I plot on the graph here. Then I get the same shape. Do you understand these 2 diagrams?
Yes.
Then I combine these 2. I get this diagram.
Uh,
All right. Now, I explain about the second diagram I draw here.
okay.
What is all this diagram? If I have 2 number there, 2, 0. This is x, this is y. Correct?
Yes. Yes.
So if I want to refer to this number, This is point number what? Number 2, right? No,
Yeah.
this is point J. So this is basically Jx and Jy. Do you agree?
Yes.
Okay. So if you look at the first example, beta I equal to yj minus ym, it just asks you what is the y coordinate for j. So you look at j, you have x and y coordinate. This is x and y. So if it asks you y sub j, you're looking for y coordinate, which is 0.
0.
Then the second one, it asks you for ym, referring to point M. So you have x and y again. So it asks you the y coordinate, ym. So it is 1.
Okay. Okay.
Ah,
Now I understand.
ah,
So BJ will be
what?
1 minus
Minus what?
1 minus minus 1. So it will be 2.
Okay, correct. Now you understand, huh?
Yes, perfect. Thanks.
Okay. Singi, now it's your turn to answer B sub M. What is the answer?
-1 minus 0 equal to -1.
Okay, correct. Lai, your answer. Lai, your turn. What is the gamma I?
0 minus 2.
0 minus 2 equal to -2. So all of you understand how you get the value already. So I just proceed. Okay, so bi minus 1, bj 2, beta m, and so on. Okay, so you put one side all the 6 number. Okay, then recall there's one more slides for the beta I, b1, bj, and bm. There's one slide. Okay, which is the strain equal to B matrix D. So B equal to BI, BJ, BM. So this is the standard form of the capital B matrix. If you want to calculate capital BI, you use this matrix. If you want to calculate BJ, you use this matrix. You want to calculate capital BM matrix, you use this matrix. Okay. Back to the slides here. So you want to calculate B, you use this equation. B equal to 1 over 2A, and then the beta I and so on. This is a standard form. So you just now you calculate the what is beta I, beta Z, beta M, gamma I, gamma J, gamma M. So you just what you do next is just substitute all the number inside this matrix. You get this B matrix value. Okay. Then after that, you know how to calculate D and B already. So what is D? I show you how to get the beta matrix. The next slide is about the D. The A, the A. How do you get A? A basically is the area of triangular. So if you don't know how, if you have a complex shape of triangular, you use this equation. 2A equal to this one, and xi, yj minus ym. This one is the coordinate, like what I showed Katana just now. Okay, you just substitute and then you get the value. Remember to pull these two to the right after you calculate, yeah? To get the A. So I will show you this equation. So A is the area. So this is a straightforward triangular. So you can use the normal mathematics to calculate the triangular area, right? Half BH, half the height and the base times the height. You get the area. In this case, the area is 2 meters square. Let me know if you don't understand. If you look at the diagram, you don't understand why the area of the triangular is 2 meters square. Let me know. Lai, you understand why you get 2 meters square based on the question? This is a very straightforward triangular.
Oh, yeah.
Okay. Katana, you understand why you get 2 meters square?
Yes, sir.
Okay, good. Move forward. You substitute the value inside the equation above. 1 over 2a, get 2. D, how you get D? D is from the standard equation. D equal to E divided by 1 minus portion ratio 2, 1 portion ratio, 1 portion ratio, 1 minus portion ratio divided by 2. So this is standard already. Okay, you key in the value because E is given, portion ratio is given. You calculate, you put in the matrix form. Then you use the calculator that I showed you last lecture. You times lah. So the first one, you use matrix A times matrix B. You key in DB. Then you put to one side. Then you calculate the transpose B. You times the products of these two. And then you slowly times the A times the T. Then you get the K matrix. All right. So we are clear with this tutorial question. Next, we look at the same case, but this one is a stress problems. Huh? So you read from the slides here. So stress equal to D matrix times the strain. Again, the D is repeated again, standard form. So this example, I'll show you how we solve this one. Yeah. So same, you calculate, you will get this answer. You substitute E divided by 1 minus portion ratio, and then you calculate, you'll get the matrix form. Okay, I just show you the steps. Huh? So you get the B, you get the D thickness you have. So once you calculate using the calculator that I show you, you take the 1 minus 1, 2, thickness is 0.1, area is 2. Matrix transpose, sorry for the sign, this one should be it should not use the curly shape, it should be the bracket. So transpose means you transpose the matrix B, the row will become column, column will become row, right? And then, right? Then you put in the dB, you calculate the dB. This is a very lengthy calculation, but with the online calculator that I show you, it should be easy for you, right? So with this notes here, you're able to find the K. So you get the K metric, 6 times Z metric. Then again, practice using the online tools. So you get 6 times Z metrics. Yeah. Then you use the stress equal to D strain matrix. This one. So you do conversion. Stress equal to dB times the displacement. You have the D, you have the B matrix already. You have the displacement standard form. So B, D matrix that you calculate previously. And then the displacements was given. The U1, V1, U2, V2, U3, V3 is given. So you put this information in the displacement matrix here. What I show on the screen here. So stress equal to D. This is D. This is B times the displacement that is given in the question. So you put in the matrix form. Use the calculator again. You will get answer lah. So you get the stress in X direction, Y direction, and the shear stress in XY. Okay. Then the next one, you need to change the X and Y and strain into principal stress. Principal stress is given by this equation. When we start the lecture today, I show you this equation. Stress principal 1 and principal 2, basically you substitute what you get from your answer just now. Stress X plus X stress Y plus square root of your stress S minus stress Y square divided by 2 square plus the square of your shear stress. You get stress 1. Same, You replace with a negative, we'll get another answer for principle number 2. Then you use the shear stress, shear Y, and strain value to get the theta, tan 2 theta principle equal to this equation. Then you can get all the answer. All right. The next one, the next slide is also same, but this one is just now we look at the triangular cases. All right. Now what happens if you have rectangular cases? Right. Now in this case, we will show you the rectangular cases. So same, we have a plane with the height of 10 meter, 20 meter, thickness is 1 meter, and you're having a stress in this direction, T equal to 1000 Pascal, and you have a thin plate. Here we need to find the nodal displacement and stresses. Same procedure. So how do we do it? So first you break into small pieces, discretization. We call it discretization. In ANSYS we call it meshing. So you break into two, you see it as a 2D cases. You break into two rectangular. You break this rectangular into two triangular, element 1 and element 2. Okay, then you calculate one set, one triangular set just now. Just now I show you one set, the example just now in tutorial. One set. In this example, you need to do two set. One for one element, triangular number 1. You do one set, then you do second time triangular number 2. So this kind of question would be very similar to your final exam question. You need to break the cases into 2 element or 3 element, depends on the cases. Okay, so I just repeat the same process. So we look at the first element first. You break into 2. So how you find the forces in the element? By using the stress equation. Stress equal to, stress equal to force divided by area. So T, this T is a tension stress. So T equal to force divided by A. So we want to find force. Force equal to T times area. Okay. However, your force is half of it. You divide by half because you break the stress T here into two forces. Right? You convert the diagram on the left or on the right to the left here. You have 2F here. You have 2F here. So you break into half. So half TA. Right? That's why you have this one, yeah? So I show you the derivation already. So each one of the F here represent half TA. So I calculate for you, just a side note for you. T is 1000 Pascal. Pascal is Newton over meter square. So this one should be capital N. Capital N. Typo error, yeah? Area, how to calculate area of this rectangular? You just take 10 times 20. Sorry, this not 10 times 20. Area is this one. I highlight on the screen here on the diagram. On the diagram on the right here. So the one that I highlight with the red ink here, what is the cross-section area of this stress? Because you know that stress always acting on the area. This is the stress by the T stress. I highlight with my pen. So this one equivalent to here. So what is the area of this one? Is 1 meter times 10 meter here. So that's why 1 times 10 here. So the forces in your calculation is 5,000 Newton. 1F is 5,000. So 5,000 by 5,000 total is 10,000. Yeah. But when you do analysis, we look at individual F. Once you find the F, you can continue. You have the governing global matrix equation, F equal to KD. So this is a capital F. We look at global scale. So you can expand F equal to KD in this this kind of matrix. So your F form, remember you need to look back at the question itself. So this question you have 4 points, point 1, point 2, point 3, and point 4. So that's why in the matrix you will have F1x, F1y, and so on. You have 8 degree of freedom because each point have 2 degree of freedom. You have 4 points, you have 8 degree of freedom. So F1x, F1y, F2x, F2y, and so on. And then the K matrix times the displacement. So you have 8 degree of freedom. So you have 8 displacement there, U1, V1, and so on until point number 4. Okay, so this slide should not have any problem. Stop me if you're not able to understand why there is a 8 point there. Okay. All right, so your K from these slides, you know that your K is 8 times X matrix. It's a very big matrix, yeah. So it's 8 times X. However, after you applying the bounding condition in this diagram, you see that point 1 and point 2 not able to. It's a pin. It's not able to move. So you can cancel, not cancel, but you can close the matrix according to the bounding condition. Point 1, you close 2 value there. Point 2, you close 2 value. So actually you close 4 degree of freedom. You reduce 8 times 8 matrix to 4 times 4 matrix. Okay. And then this is the substitution of all the F value that you have. So F matrix, I substitute the value for you. So 1 will become R1x. You can continue to use F1x, no problem. But only I substitute the respective number there. So you can see point number 3, the direction is along x-axis. So I replace F3x with 5,000. There's no y direction for point number 3, so 0. Point number 4, x direction, I have 5,000. Y direction, I don't have force, I get 0. And the displacement here, point number 1, U10, V10, U20, V20, and you have a displacement at point 3 and point 4. So this is the first set of equation that you should see on your answer sheet. Yeah? Then after that, after you done with the F equal to KD, the global scale, after you have set your direction for your solution, then you look individually into the K matrix here. So K matrix here, you use all the standard equation. K matrix here is a small k. Yeah? K, you keep repeating this equation. K equal to TAB, again, typo error. This should not be a curly bracket. It should be a normal bracket. B transpose DB. This is a small k. It means that we look at element. You do for element 1, one set, and then you do, after you done for one set, you repeat for element number 2. I do the first element for you. So element, you pull the triangular out, element 1. So you have 1, 2, and 3. Again, when you pull the diagram out, always remember the direction of your labeling is always anti-clockwise. You have your point I, point J, and point M. You always label in the anti-clockwise. So point I, point J, point M. However, the numbering of the point, you have to follow the diagram in the question. What is important is your I, J, M should be in the anti-clockwise direction. However, the numbering, you should follow the diagram. So why M equal to 2? Because the diagram gives you 0.2. Why this one is 1? Because diagram gives you 1. Why the J is 3? Because diagram is 3. Okay, clear? Don't confuse with the direction. Okay, labeling anti-clockwise. However, the numbering, you should follow the diagram in the question. Okay, so for element 1, your first point, if you look at the diagram, your axis y and x is referring to is stationed at point 1. So your point 1, xi equals 0, yi 0. I repeat the same. Xj equal to 20, yj equal to 10. Like you understand why suddenly your this point yj here, this is your j point. Why this one is 20, 10. Like you understand? Like, do you understand? You compare the diagram above. Are you able to link?
Yeah.
You okay?
Okay.
All right. Singi, you okay?
Yes.
All right. Katana, you understand why this point is 20, 10?
Yeah, like the 2D of the.
Yeah, you compare side by side, huh?
Yeah.
All right. Then same with the third point, the m. Xm equals 0, ym equals 0. Ym equal to 10, sorry. So what is the point? What is the reason why we need to know the coordinate? Because this coordinate can help you to calculate your b. You remember the 9 equation? Just now, the example just now, you just substitute all these xi, yi, xj, yj, xm, ym in the equation, the 9 equation just now. Then you can find b. Okay, a in this case also very direct calculation. Triangular area half bh. I do it for you on the screen. Or you can use another calculation. It is a 2a equal to this lengthy equation. Same, you'll get the same answer. All right. Again, A is the area of the triangular. Then you evaluate the B with this matrix, B equal to 1 over 2A, and the B beta I, gamma I, and so on. This one I did show you in the previous example. You just substitute the coordinate that I showed you just now. So BI, BJ, and so on. Okay, you substitute with the coordinate, you get the answer. I show you on the screen here. Okay, it should be very direct. So for example, beta I equal to yj minus ym. Yj is here. So this coordinate is 20, 10. So yj is 10. Ym is here. So coordinate for m will be 0, 10. So you put your ym 10. So the equation is yj minus ym. So 10 minus 10 gets 0. Same with other equation. After that, substitute back to this equation. You get this answer. The dimension is 1 over meter. Okay. After that, you calculate the D matrix, standard equation. Standard matrix, modulus Young is given, Poisson ratio is given. Substitute all the value. So in exam, this equation should be a free mark for you. You should not able to make any mistakes. It's a standard equation where all the numbers is given. Okay, this should be an easy score for you. At least this is 1 mark for equation, and then substitution answer is another 2 marks. So here is 3 marks already. So it's quite easy to score. Just be careful when you press the calculator. There's a human error. That part I cannot help you. All right. Substitute answer, you get this one. Then the rest is the substitution. You have your B, you have D, you have the A value, B transpose, and the thickness T here is given. So you use the online calculator, put in all the value. You do, or you can do manually if you want. If you manage to do hand by hand, go ahead. All right. But for coming exam, you are allowed to use online tools to help you. So after you do the B transpose D, you get this form. And then you do the calculation, you get this form, and so on. You'll get your K matrix for element 1 equal to this one, and the constant value in front, be careful, yeah? Constant value in front, be careful, because when you combine into global matrix, you be careful, when you combine the stiffness matrix, the constant in front must be the same. When you combine K element 1 and element 2 matrix together, you superimpose. Be careful on the constant value in front. A and B must be the same when you pull them out. So they will be C K matrix plus the K matrix number 2. Be careful on the constant value here. So this also another area of error when it comes to exam. Be careful on this one. All right, when you superimpose into global matrix there. So this one also be careful. The coming Wednesday test, number 2, just a reminder, be careful on the constant value for element. When you combine into stiffness matrix, global stiffness matrix, be careful to convert them or factor them into a same factor when you combine them. Okay, yeah? You understand? Lai, you understand what I'm talking about?
Yes.
Singi, you understand what I'm talking about?
Yes.
Okay. Katana, you understand not?
Yeah, to have the same multiple, is it?
Yes, correct. Means if you found a, let's say you find the element number 1, your K matrix equal to, let's say, 100, and then there's a matrix inside there lah. Then you find element 2, you only get 5 times the matrix inside. So when you combine these two, the K matrix, global matrix, it must have the same, you must convert the first one into 5. Sorry. You must convert your first matrix into 50, and then all the 50 times 2 means that the matrix inside there, all the matrix there, you times 2. Means that the K matrix global, you only see 50 outside. You understand? Katana, you understand?
Yes. Wait, that was the first K was 100, right? Or 10?
Yeah, 100. The first, let's say your first
Yeah.
element matrix is 100 times all the matrix there lah.
Yeah.
Yeah. So let's say you get 1, 1, 1, 1, 1 like that lah. Then this one also you get 2, 2, 2, 2 inside. So when you combine these two, you need to make sure the matrix in front is the same. I mean the constant is same. So you convert, how you convert this one, the matrix will convert into 50 times 2. Then 1, 1, 1, 1, 1. Then you need to convert this one into 50. And then this one is become 2, 2, 2, 2, 2 matrix. You understand?
Yes, sir.
Then you only can do superimpose. Remember, element 1 and element 2 will be different. All the number inside there refer to the different coordinate that you need to be careful. For example, just remind you on these slides, for element 1 here, you are looking at point 1, point 3, and point 2. First two column refer to point 1. Second column, point 3. Why point 3? Because this is the second point. This is I, this is J, and this one is point J. Point J, according to the question, is point number 3. So that's why you have a U3, V3 there. And then this is the third point in the diagram. So third point in the diagram is point number 2. So you have U2, V2. Be careful on the notation. Okay. So in coming test 2, This also one of the area that I try to trick you. So be careful. Okay, so it's not always that smooth. It's not always U1, V2, V3. No. You have to look at the question and put according to the coordinate given. So in this case, the first two columns is referred to point I, which is point number 1. The two columns in the middle here refer to the second point, which is in this case is J, and J refer to node number 3. So that's why you see U3, V3 there, and it's not U2, V2. And then the third, the last two columns here refer to the third point, which is in this case is point number M, and point number M was given a node number 2. So that's why you're having a U2, V2 there. Be careful, be careful on the arrangement of the location for your number. Because this one later you superimpose, you need to be careful when you put them back. Okay, done with the first element. You repeat the same process, use the same matrix form, K equal to T, A, B, T, transpose D and B. So this one, go ahead and do homework. So this one just a side note lah. So this one is just explain why suddenly these two column is 1, the middle become 3, this one become 2. We are actually referring to the anti-clockwise labeling. Then point number 2, we repeat the same, and we label the element again. I, J, M with the anti-clockwise direction, and then we put in the node number 1, 4, and 3 according to this diagram. Okay, you need to separate the direction of I, J, K anti-clockwise and the node for each one, the node location, location for each one. This is M, not K. You repeat the same process for element 2. Same process, element 2, you get this matrix. I'll show you the steps lah, so you can look at the screen here, and then you get the same area. You get the B and D again. Repeat the same. However, the coordinate will not be the same. Repeat, calculate for the beta I, gamma I. Repeat the same. Then you do the calculation for D matrix again. So D matrix will be different if the Poisson ratio is different, but normally it's the same because you are looking at the same object. Unless you're doing a composite material. In this case, we do not look at composite. In your final year project, maybe. So this one will be different. All right, so you combine all the metrics together like what you did for element 1. We are looking at element 2 now. At the end, you arrive at element 2 K matrix. Again, you look at the labeling that I do for you. The first one is for I. Second one is J. The third one is M. And you look at the diagram that you draw for, sorry, this one should, I give you the wrong diagram. This should be element 2. Sorry, this one is the wrong one. It should be element 2, which is 1, 4, 3. So that's why in this matrix here, the first two column is U1, V1. Second column is U4, V4. The last two is U3, V3. This is a wrong diagram. We should using this one. Okay, your homework to prove this matrix again. Be careful on the constant value outside the matrix. This one, it should be the same. You should factor them out and then put them the same before you do the superimpose. Then you do superimpose. Superimpose, I do it on the screen here. Just a side note for you to help you for your revision. So in this case, these two is the same. So you have a direct case. Just a reminder for your coming test 2 this Wednesday. I purposely changed the value inside, so you won't get the same factor. So you need to do factor out to combine to become the k factor. Just take note for this coming test. All right. So element 1, K1, element 2. Okay, so element 1, I changed the matrix here. I just do some. Okay, so what I do, because if you superimpose, you see the element 1 here, you have 0.1, 0.3, and 0.2. And for element 2 is 0.1, node 1, node 4, and node 3. So when you superimpose into a global matrix, you should start with 0.1, 0.2, 0.3, 0.4. So you need to rearrange according to the coordinate itself. You need to smartly arrange the value according to coordinate itself, like what I'll show you on the screen here. I transform my element 1 matrix into U1, V1, U2, V2, U3, V3, U4, V4. I rearrange the matrix in this solution. There's, for example, and then I change the constant value in front also. All right. So this one you need to do as your homework. I show you the final answer. The concept you should understand. Yeah. So what I do here on the screen here, I modify my location of matrix here. I add one more column and I rearrange the matrix from node 1, 3, and node 2 to 1, 2, 3, 4 point. That's why if the respective coordinate, you don't have the value, just put 0. You do it the same for element 2. So element 2, you have 0.1, node 1, node 4, and node 3. Again, you do it, you modify the matrix again to 0.1, node 1, node 2, node 3, node 4. Then be careful on the constant value in front. After that, you superimpose these two together. You'll get this form. So this is just a reference answer for you. You will combine 1 and 2 accordingly. Okay, this is the homework. This is homework. And the online matrix won't help you to do all this. You need to know how to park all the number correctly. Okay. After that, you use F equal to KD again. You already found your K already. You already found your K. And you have all the 8 equation here. You have all the 8 equation here. So I put the answer for you. Rx1, so on. K, D. You solve the matrix. You apply the boundary condition. Means you close if you have a constraint, not able to move point. In this case, 0.1, 0.2, not able to move. You close the matrix accordingly, like what you learned in your chapter 3 and chapter 4. You close accordingly to the coordinate. You only arrive at 4 times 4 matrix. Like this. Okay, 4 times 4 matrix, you have 4 equation, 4 unknown. You're able to solve. Or this one, you can use online matrix tools to help you. You just inverse this one, time this matrix, you get this 4 value. Okay, you'll get this value. You just check. Use the tool to double check this answer. Homework. This is your homework. Okay, then the next you use the stress equation. Stress equal to dB displacement matrix. This equation. You already know the D, you already know the B already. You already know the displacement from previous answer. So you just substitute all the numbers inside at the end, and again this multiplication of matrix, if it looks complex for you, just use the online matrix tools for you to solve the question. And then stress, and then you get the 3 value there. Okay. The unit for stress is Pascal, yeah, or Newton over meter square. Be careful on the unit. So this is how you solve for this kind of question. Okay. So you substitute, you get the answer. So this one is for element 1. You do it for element 1, one set. Then you do it another for second set. You get these 2 number. All right, then you can calculate the principal 1 value. You get this one. Principal 2, you get this value. You can calculate the angle also by this equation. You get 0. Again, homework for element 1. Okay, so this is how you do it when you are given a plane stress problems. Okay, have a look in my PowerPoint slides and then do it as your revision. Okay. Right, with this I end the recording.